Hi friends, so we're going to learn about how to solve a system of equations using substitution. Up until now we've been using elimination, so today we're going to look at how substitution works. The goal of substitution is to solve one of your equations for a variable, either x or y, and then you're going to substitute that into your other equation. So let's take a look at these two here and see how we're going to do that. So I want to pick an equation that's going to make my life easier, because when I'm solving for my x or my y, I have to think about what that's going to entail. So here, like if I pick the second one, I'm going to end up with some fractions, right? Because I have coefficients with my variables. I'm going to have to divide by either 3 or 2, and I'll end up with some fractions. And I don't know about you guys, but I like to try to avoid fractions to make my life a little bit easier when I can. So let's look at this top one. Let's take our top equation, and let's solve that, let's say for x. I'm going to rewrite it here, and I'm going to solve it for x. So if I want to get x by itself on this side, I need to move my y over to the other side. Here I'm adding my y, so to get rid of addition, I'm going to do subtraction. So I'll do minus y on both sides. And that will give me x, my y's cancel out, equals 1 minus y. So now that I've solved for one of my variables, right, that was part of my goal of substitution. First, I have to solve for one of my variables. Next, I'm going to plug it into my other equation. So this is important. You can't go plug it back into the same equation that you started with. You have to use the other equation. So here I'm going to use this one that I start. So I'm going to rewrite it down here. 3x plus 2y equals 4. And then I'm going to plug in this variable that I solved for. So you see here, x equals 1 minus y. I'm going to take this 1 minus y and plug it in for x in this other equation. So I'm going to rewrite it. Instead of x, I'm going to write this whole thing. So 3 times 1 minus y, right? I plug that in for x. And I want to make sure to include my parentheses here, or else my distribution will not work out right. So make sure if you have multiple terms here that you're plugging in, you put parentheses around them. That way you're going to be multiplying this 3 times this whole thing you plugged in for x, right? Because it's 3 times x. So you want to make sure that all of x is being multiplied by 3. So those parentheses are very, very important. And I'll just continue writing my equation. So I had my 3 times x plus 2y equals 4. So now I'm going to look at this and think of what's the first thing I should do. We're going to distribute our 3. So same way that we've been doing with distribution, you want to make sure you distribute it to every term inside of the parentheses. So 3 times 1 is 3. 3 times negative y is negative 3y. Then we're going to continue writing the rest of our equation here. So plus 2y equals 4. So now we're going to combine our like terms. So here I have negative 3y and 2y. I'm going to combine those to give me negative y. And then we're trying to solve for our y here. So what do we have to do to get y by itself? We have to move our 3 over to the other side. Subtract 3 from both sides. So negative y equals 1. And then we're looking for y equals something. We almost have it. We have negative y equals something. So how are we going to get rid of that negative y? Well, you can think of negative y as negative 1 times y, right? So there's an understood 1 there. So I'm doing negative 1 times y. If I want to get rid of multiplication, I'm going to do division. So I'll divide by negative 1 on both sides. So then y is going to equal, because these ones cancel out, right? So I end up with y. And then I have a positive over a negative. That's going to give me a negative 1. So now I have my y equals negative 1. And it's going to be a lot like when we did with elimination. Once you do this, the hard part's over, right? You have one of your variables. Now all you have to do is go back to your original equations, pick one of them, and plug it in. That way you can get your x out. So you can pick whichever one you want for this. I'm going to go ahead and pick the top equation. So let's do x plus y equals 1. And then I'm going to plug in. So plug in my y equals negative 1. Plug it in for this y here. So I'll rewrite it, x plus -1 equals 1. If I'm adding a negative, that's the same thing as subtracting, right? So I can just write it as x minus 1 equals 1. And then I want to get my x by itself. I'm going to add 1 to both sides. So I will get x, those cancel out, equals 1 plus 1, which is 2. So now I have my x, I have my y. Now I need to write my solution as an xy coordinate pair. So it's going to look like this, xy. And then I'm just going to plug these in. So here my x equals 2 and my y equals -1. So that's going to be my answer, 2, -1. Remember we talked about before, this answer that we get, that means that's the point where these two lines are crossing each other. And just to show you that for substitution, it doesn't matter. Whenever you're solving that first problem, it doesn't matter if you pick x or y to solve for. You just want to pick something that makes your life easier. So we could have solved, instead of solving for x originally, we could have solved for y. So let's solve it out down here, solving for y, just to show that that's possible. So I'm going to pick this top equation again. And then now instead of solving for x, we're going to solve for y. Okay, so let's subtract our x on both sides this time to get y by itself. So these will cancel out. We get y equals 1 minus x. Remember, we have to go back and plug it into our other equation. I can't pick my equation I started with. I have to pick my other equation. So I'm going to put a star on that one. I'm going to come rewrite it over here. And then I'm going to plug in this whole thing that y equals, so it equals 1 minus x. I'm going to plug it in to this equation here. So let's rewrite my equation with this plugged in for y. I have 3x plus 2 times that whole thing. Remember, parentheses are really important. You have to put it in parentheses. Equals 4, right? So we have 3x plus 2 times the quantity 1 minus x equals 4. So now I have to solve this. I'm going to distribute my 2 to everything on the inside there. So 3x plus 2 times 1 is 2, plus 2 times -x, it's going to give me -2x equals 4. So now I have to combine my like terms. So I'm going to rewrite it so my like terms are next to each other, so it's a little bit easier to see. So I wrote my x's next to each other. So now I can see my 3x minus my 2x, that's going to give me x. So x plus 2 equals 4. Subtract my 2 from both sides. X is going to equal 2. So my hard part's over. Now I'm going to go up, pick one of these equations, plug that x in. Doesn't matter which one you pick. I'll pick the bottom one this time because last time I picked the top one. Absolutely does not matter. So I'm going to rewrite that. I'm going to plug in my x equals 2. Plug it in for that x. So 3 times 2 plus 2y equals 4. 3 times 2 is going to give me 6. I'm trying to solve for y here, right? I already found my x. I want to find my y. So I'm going to subtract my 6 from both sides. I'm trying to get my y by itself. 2y equals -2. Divide by 2 on both sides, right? Because to cancel out multiplication, I do division. 2's will cancel out because 2 over 2 is 1. I get y equals -2 divided by 2, -1. And then I want to write my answer in xy coordinate pair form. So I have x equals 2, y equals -1. My answer, again, is 2 equals -1. Or sorry, 2 comma -1. So you can see here, no matter which way you do it, if you solve for x first or if you solve for y first, you're still going to get the same answer. So it doesn't matter which way you do it. So let's do one more example together, example 2 in your guided notes. So our first step here, well, let's keep our goal in mind. Our goal is to solve one of my equations for a variable, either x or y, and substitute that into my other equation. So I want to pick the equation that's going to make my life easier. So let's look at this top one and think about it. If I pick this top one, I'm going to have to either divide by 2 or divide by -3, because those are my coefficients here for my variables, and I need to solve for x or y. So if I divide by 2, I'm going to end up with -3/2, which is going to give me a fraction. I don't like working with fractions very much. If I divide by -3, I'm going to end up with -2/3 as one of my fractions, which we can work with fractions. It would be fine, but if I can avoid it, I'm going to. So let's take a look at my second equation, see if I'd end up with any fractions here. So I'd have to divide by 4 if I end up solving for my variable x. If I divide 8 by 4, I'll get 2, and that's a nice whole number. If I divide 24 by 4, I'll get 6, and that's a nice whole number too. So here, if I use this bottom one, I'm going to avoid having any crazy fractions happening. So I'm going to pick the one that makes my life easier. So you could just like go into this and start working, but it's really helpful if you start off and try to think, how am I going to make my life as easy as I can? Take that extra 30 seconds to think about it. So I'm going to take this problem, this equation, I'll rewrite it over here. And just like before, it doesn't matter if we solve for x or y, you're allowed to do either. But we just decided that if we solve for x, it's going to give us some nice whole numbers instead of fractions. So let's solve for x here. So we're going to try to get x by itself. I'll subtract my 8y from both sides. So 4x, those will cancel out, equals 24 minus 8y. Divide by my 4. Make sure to divide every term on this side by 4. Right? So these cancel out. I get x equals 24 divided by 4 is 6. And then -8 divided by 4 is going to give me -2. Make sure you keep your y in there, right? It's not just -8, it's -8y. So to make sure I have my y. So now I've solved my equation for x. And if we think back to our goal, we want to solve for a variable and then plug it into our other equation. It's really important we use our other equation and not the same one we started with. So I'm going to rewrite that equation down here. 2x minus 3y equals -2. I'm going to take all of this here that x equals and plug it in for x in that equation. So I'll rewrite it with this plugged in for x. So 2 parentheses 6 minus 2y, those parentheses again, still very important. Then continue writing your equation. It's minus 3y equals -2. We're going to solve it the same way we have been. First, you distribute your 2 to everything inside those parentheses. So you have 12, because that's 2 times 6. And then you take 2 times your -2y, -4y. Then you continue writing your equation here. Minus 3y equals -2. Combine our like terms. These both have y's, so they're like terms, right? So -4y minus 3y is going to give me -7y. I'm going to solve for y, so I want to get rid of my 12. So -7y equals -14. Right? -2 minus 12 gives me -14. Divide by -7 on both sides. Y equals -14 divided by -7. It's going to give me 2, right? Because a negative divided by a negative is going to give me a positive. Y equals 2. So once I have this, I've done the hard work, I'm going to go back up, pick one of my equations, and plug it in. Doesn't matter which one you pick. Let's just do the top one. So I'm going to rewrite it. 2x minus 3y equals -2. I'll plug in my y equals 2. Plug it in here. So 2x minus 3 times 2 equals -2. 2x minus 6 equals -2. I want to get my x by itself, right? I already know my y. I'm trying to find my x. So let's add 6 to both sides. 2x, just cancel out, equals -2 plus 6, which is 4. divide by 2. X is going to give us 4 divided by 2, which is 2. I want to write my answer in xy coordinate form. So my x here is 2. My y is also 2. So my answer is 2, 2. The point 2, 2. And that, remember, is going to tell us where these two lines cross. They cross at the point 2,